Okay, here's the video walkthrough of the quiz that you're working on for this week. This is a randomly generated version of the same quiz that you're working on. In the first problem, we're setting up simple exponential growth, and notice that we don't have the word continuous with growth here. We're just saying this grows, the population grows by percentage each year. And so that tells us we're not using our P times E to the RT formula. Rather, we're thinking of this in terms of starting off with 18,000, whatever these are, bacteria, whatever that is, times 1 plus the growth rate. So we convert that to decimal. Oops. If I could write clearly, 0.177. So remember the 1 plus here is basically saying that we keep the amount we had and we add on 17.7%. So 1 plus 0.177, and then that's raised to the t power. And that will be how much we have after t years. And once again, the reason I know it's years is because I'm told that that's the growth rate per year. So to put it in your calculator, you wouldn't write that the base there as 1 plus 0.177. You would just go ahead and add those numbers together. So we would say 18,000, 1.177 to the t would be our formula for P of t. Now, just to remind you, the 0.177 there comes from converting the percentage. Don't forget that 17.7% literally means 17.7 parts per 100. So those are the same thing. So if you're not sure what the right number there for the decimal version of the percent is, just divide the percent number that you're given by 100, and that's the decimal that you're going to use. All right, now, by contrast, number 2, we're told that we have a continuous growth rate of 4% per year. And so that's our clue that we're using the model P times E to the RT, where again the P here is the initial amount and the R is the growth rate, because this population is growing in a positive way. We would use a positive percent. So this 4% per year, again, we'll convert 4% into a decimal by dividing by 100. So 4% is 0.04, and we would use positive 0.04 because this is positive growth. So our model then is the initial amount, which we're getting from here, times E to the 0.04t, and that's going to be the population and I'll just read it off here, t years after the year 2000. Once again, the fact that this is measured in years is coming from the fact that that rate is per year. So if those units weren't the same, if we were given a monthly growth rate and asked for years, then we would have to convert one or the other of those over to the other value. They all need to be the same. And then part B says use that population to find the population. Use that formula to find the population in 2008. Notice, I'll write here. Notice this is not asking for P of 2008, and I'll put a bunch of exclamation points after it. The reason is that P of 2008 would mean. Oops, hang on. That's not what I meant to do, right? So P of 2008 would mean the population 2008 years after the year 2000. That is not what we mean. If the input is supposed to be the number of years after 2000, then the value that I would want to evaluate here would just be P of 8. So if I just read what I wrote, then I can say P, oops, I'm in trouble with my colors today, hang on. All right, P of 8 should be population, right? I'm just writing down what I wrote before, but P of 8 should be the population 8 years after the year 2000. And that is what we want. We want the population 8 years later. So P of 8 should be what we're evaluating. And so that'll be 19,400 times E to the 0.04 times 8. Now let me just do, I'll find the value of that so you can check that you're using your calculator correctly. And I'm getting that this is, again, we'll round this to the nearest whole number because we don't want to see 0.27 of a fox. That would be gross. So just 26,716 is what I'm getting. The key thing there is to put the exponent in parentheses in your calculator. So it depends on what kind of calculator you have, but if you're, let me just erase this. If you're entering this into a lot of calculators, you would want to make sure that you put the, just like a time symbol in there. So if you put in parentheses 0.04 times 8, then you'll be in good shape. If that seems weird to you, then just do that 0.04 times 8 calculation first. 0.04 times 8 is 0.32. And so you could just say 1940 times e to the 0.32. But the biggest problem people make is that they don't raise this whole thing to the power. So that's just getting used to your own calculator. Stick your head in the tutoring room at MCT 252 if you're not getting the right answer and you want someone to help you see how to do it on your calculator. This is a question similar to what we were doing Wednesday of plotting points. So here is our here's our formula, and you can see that that I actually have a vertical shift here now. I've added something to the base exponent, and we were talking about that a little bit yesterday, but we didn't actually draw any that looked like this. So I can just plot some points. I'll do the easier ones first. So like f of 2 will be 2 to the 2 squared plus 3, so that's 7. F of 0 is 2 to the 0 plus 3, which is 4. A different color. F of negative 1 is 2 to the negative 1 plus 3, which is 3.5. And you should just check these. I'm just plugging into the formula, plugging values back into the formula. And f of minus 2 should be 3.25. And so if I've evaluated those output values, then each of those corresponds to a point given by its input comma output. So every time I evaluate the function, it corresponds to a point. And so then I can graph these. The 0.27 is here. The 0.04 is here. Negative 1, 3.5. And negative 2, 3.25, like that. And so what's going to happen with the shape is that it's going to look like the same shape as all the pictures we were drawing Wednesday. But because we put this plus 3 out here, we know from section 1.5 that that has the effect of vertically shifting the graph up. So what you're seeing here looks exactly like the graph of 2 to the x that we drew on Wednesday, but all of the y coordinates are shifted up 3 units. But we can get that sense from just plotting points. On this problem, on the quiz, you're just going to plot the points. You're not drawing the final curve.